Hi everyone, this is going to be our moment curvature tutorial. To start, you need to set up the exe for OpenSees path. So go ahead, click in File, set OpenSees path, find OpenSees in your computer, and OK. Now you can create the nodes going to Edit, Node, Add. There are 2 dimensions and 3 degrees of freedom, and you can assign the coordinates of the nodes. Both nodes are coordinates 0. Okay, and the next step is add the element going to Edit, Element, Add, and here's 1, 2, 2. Display. Now we should assign the nodes constraints with boundaries conditions. Go to Assign, Node, SP constraints. Node 1 is all marked. And node 2 does just bi-direction. Okay. Now we are going to define the materials. Go to Define, Materials, Uniaxial Materials, add a concrete. This is your core concrete. The next one is your cover concrete. Here is -6, -5, 2, -0, and here is -0.006. And the last one is a steel, and you can call this as reinforcement. 60, 60 as yield, 30,000, and hardening ratio as 0.01. Okay. Now we are going to create the line sections. Going to define sections, line sections. You create a fiber, name as column. So we are going to add the paths. The first one is core. The core concrete. The coordinates are -10.5, 6, -10.5, -6, 10.5, -6, 10.5, 6, here's 1, and 10. Again, quadrilateral. This is the top cover. Cover concrete. The coordinates are 10.56, 10.5 -6, 12 -6, 12, 6, 1, and 2. The next one is bottom cover. Cover concrete. The coordinates are -12, 6, -12, 6 minus 10.5 minus 6 minus 10.5, 6, here's 1 and 2. And again, this is going to be our left cover concrete. The coordinates are minus 12, 7.5, minus 12, 6, 12, 6, 12, 7.5. Here is 1, and here is 10. Again, this is your right cover concrete, and the coordinates minus 12, minus 6, minus 12, minus 7.5, 12, minus 7.5, 12, 6, 1, and 10. Here, added new layer straight, name as bottom. The material is the steel one. The coordinates are minus 10.5 to 6, minus 10.5 to minus 6. Here is 3 bars and the 0.6 as area. Again, but now is the middle. The coordinates are 0 to 6, 0, minus 6. 2 bars, 0.6 as area. Again, this is the top. Here is 10.5 and 6, 10.5 and then minus 6. 3 bars, 0.6 as area. Add. Here you can check. And here clicking add to complete this process. Okay, now we are going to define the element. Go to define element, select a 0 length, rename as column, here section, column. The next is assign the elements. Go to assign, element types, element number 1 is a column, assign, display, OK. Now we are going to define the time series. Go to define, time series, constant, rename as constant 01, add, OK. Now we're going to define the load pattern. Go to define, load pattern, select the plane, here you rename as constant actual, this is a constant 01, add, and now you create the linear moment. And there is linear default. Add, OK. Now you need to assign the load on node 2. Go to assign, node, loads, load node 2. Here's the constant actual, f x as minus 180, add, and node 2, here is a linear moment, and mz equal to 0. Add, OK. Now we're going to define the analysis option. Go to define, analysis options, new analysis options, this is the actual load control, here is a static, here is const, here is plane constraints, integrator type as load control, algorithm as Newton, convergence test as normal displacement increment, DOF is a plane, the system of equation, sparse general, and add. Now is the moment, now is the moment, display control, here is the static, plane constraints, integrator type as load control, and integrator type as displacement control, control the node 2, DOF3, here's 1.948 E minus 005, here's 1, the same as here. Add solution algorithm as Newton. Convergence test is normal displacement increment. DOF plane. And system of equations parse general. And add. OK. Next step is define the analysis case. Go to Analyze, define analysis case, new analysis case. This is the actual load case. The load pattern is the constant actual, recorder default shape. Analysis options name is the actual load control, and 1 is the number of steps. Note that now we are going to save our model. Okay, and we can create the second analysis case. This is going to be called as moment case. Here is linear moment. The analysis options name is moment control. And there are 100 numbers of steps. OK, add, and close. Now you are able to write OpenSees input files and run the program. Here on TCL, moment case, moment case, lots response. Here is default shape, displacement node 2, DOF as 3, and here is default and time. Plot. Okay. This was the moment curvature without the actual load influence. Now with just a change we can see the impact of the actual load in the moment curvature. We just need to go to Analyze, define analysis case, and we can modify our moment case. And here we just need to change the previous analysis case to actual load case. And now we can run again. Plot response. Here is the first shape, displacement node 2, 0 at 3, and plot. Okay, so this was the moment curvature example.